Hello and welcome to this tutorial about the Fourier Shape Analysis software or FSA. In this video, we will see the installation instructions as well as the main functions and tools of the FSA software. This is a free software and can be downloaded from github.com/gamalielmch. On this website, you can find another software that could be of your interest. On the main folder of the FSA software, you will find the functions that are completely and detailedly described on the paper. The fsa.rar file is the executable file. The two first files are the main code files. The rest of the files correspond to secondary functions that can be called inside the main file. When you finish the download process, you will have a folder named FSA. And on this folder, you will find the FSA compressed file. Inside this file, you will find the executable file, as mentioned before. Unzip the file on the same folder or just click and drag the executable file on the FSA folder. In this way, the software will be ready to be installed on your computer. The software were developed on MATLAB and can be run or modified in MATLAB. Click on the FSA file to start the installation process and follow the successive instructions. You will need internet connection to download the platform. This process will take 15 to 20 minutes according to your internet connection speed. When the installation process is completed, you will have access to the Fourier Shape Analysis software by clicking on the icon that were created on your desktop. On the github.com website where you download the FSA software, you can also download the data test folder. Inside the data test folder, you will find the 9 figures of the 9 grades of roundness proposed by Cronbane. And also on this folder, you will find the 5 figures of the 5 grades of roundness proposed by Taylor and Petitjohn. In this video tutorial, we will use these images to test the software. To load an image, click on the Open option, Load Images. And then select the folder that contains the images that you want to analyze. On this video tutorial, we will use the 5 figures of Taylor and Petitjohn. The software allows you to load one or more images. Once the images are loaded, this will take you to the main interface of the software. On the lower part of the interface, you will find a navigator. If you load more than one image, you can use this navigator to visualize all of the images that were loaded on the software. The images to be analyzed must have been previously segmented, with particles in white and background in black. If colors are inverted, you can use the component color on the Setup menu. On the Setup menu, you will find the Untouched Edges. This option will allow you to eliminate every particle that is in touch with the border. For accurate results on shape analysis on FSA software, it is strongly recommended that do not analyze any particle that is in touch with the border of the image. This may introduce an error on the measurements. With the option ROI, you can choose the region of interest that fits better for your analysis. You can choose an ellipse, polygon, rectangular, or a freehand irregular polygon. For example, you can choose a rectangular region of interest by clicking the rectangular option. The rectangle region of interest can be modified manually. Or you can choose a polygonal region of interest and draw a polygon around a specific particle or a group of particles. On the paper of Fourier Shape Analysis, we describe the method of optimization that we use to determine the harmonics that correspond to general form, roundness, and surface texture. So, if you want to use our optimization method, you can go to the Fourier menu and click on the optimization option. By clicking in Optimization, the software will show you the results in the main interface. The red line corresponds to the general form, green line roundness, and blue line roughness. On the Fourier menu, there are two other options with constant coefficients, so the harmonics 3 to 6 correspond to general form, 7 to 50 roundness, and 16 to 50 roughness. And the second option have different constant coefficients. The linearized set coefficients allows you to set the coefficients to best fit the needs of your research. For example, if you want to set the harmonics that correspond to general form to 1 to 3, roundness 6 to 11, and roughness 11 to 15, you can calculate the harmonics in the way that is better for you. On the graph menu, you can plot the results of the analysis performed. For example, you can plot the mean harmonics of roundness. The software will plot on a graphic the values of the results of the analysis performed for each one of the images indicated by its name. On this example, we can see the mean of the sum of the images, the mean of the median of the images, and the mean of the images. To export the data, go to the Export menu. If you want to export the spectrums, click on the Spectrum option. And after that, select a name for your data file. In this example, we're gonna name it Results. And then go to the folder where you save the file. The results file can be opened with Excel. And this is an example of how FSA organized the results. Here you have the results of each of the images and the results of each of the particles in the images. On the results file visualized on Excel, you will find the normalized spectrum. And also you will find the cumulative spectrum. You will see these two parameters for each of the images. And also you will see a label for each of the particles. You will have all the information of the particles of each of the images that were analyzed. If you want to identify each particle in the image, you can go to the Label Image option. Select a folder, and the software will create images with a label in each of the particles. This is an example of an image with labels in each of the particles. And the third option on the Export menu is Range Stats. This corresponds to the range statistics. The spectrum have the complete statistics of the particles, without any processing and with all of the volume of each of the harmonics. Click on Range Statistics and select a name and a folder for your files. This results file can also be opened with Excel. By exporting the data on this form, you will have the results related to the coefficients calculated by the optimization method, which is explained on the paper. On this file are reported the statistical parameters such as mean, median, and variance, and also the sum of each of the particles and each of the images analyzed. Also, you can find the normalized spectrum data and the accumulated spectrum data. And finally, on the Help menu, you will find some tools that will help you to better understand and use this software. The user guide will send you to this video online. By clicking the About Us option, we'll send you to the websites of the developers of the Fourier shape analysis software, in order to contact us for further collaborations or just to resolve your doubts.